This session would be mostly, it would be beneficial for the people who are starting out, the people who are in students, third year, fourth year, maybe 1, 2, 3 years in their career, or even beneficial for the people who want to switch or their domain, and they might be working in some different domains right now, but they might have some interest in data science, but don't know where to start, what to do. And so I have had a lot of different questions on where this is my background. I've been doing this for the last these many years. So is it the right time for me to switch or to data science, or should I keep on diving deeper into my domains? So I'll pick up a few questions which are very common. We'll start from there and we'll move on to a basic understanding of what are the different types of work profiles. That so it's a big umbrella of data science, but a data scientist may not be a full stack developer of machine learning models. There are different teams depending upon different types of organizations. There are different teams who are working on different parts of the pipeline. And if you have an idea of the whole pipeline, well and good. And if you're expert in one of these, then that's good to go. So it's very difficult, or it's really not easy to be a master of everything in data science. Okay, great. So first of all, I'll start with why this topic, right? The road to data science, it's different for different people, right? Different people might have different backgrounds. Somebody might be switching right after college. Somebody might be switching after 3 to 4 years of experience, or maybe even more. So just imagine or recall going back to school. So your school was in one place, right? But there were students traveling from a lot of different areas. So two of them might come from the same area. Somebody might come from less than 5 minutes away. Somebody might be coming from 1.5, maybe 10, 15 kilometers away. So the starting point for everyone was different. But in the end, all of you reach school, right? So that's how, or that's what the road to data science is. Right now, you might have somebody might be an engineer, somebody might be doing some BSc, somebody might be MSc, masters. The backgrounds might be different, but if you have interest, if you want to get into data science or in the data field in general, then all you need is the interest and a good motivation, right? And so I'll share with you what I did and what my path was. As Lakshmi mentioned, right, I didn't have a coding background. So I did my engineering in a non-circuital branch, which was civil. And from there, I moved on to my MBA. And post that, I was introduced to data science. So that's what the road to data science is. And right now, just imagine or just visualize yourself, or what your starting point is and what your end point is. The starting point may be different for a lot of you guys. It might not be the same for two of you, but that's how it is. So this is what we'll be covering. I'll give you an overview of what the data world looks like, what are the different profiles, and depending upon what is your interest and what are the tools. If you have an understanding, if you already worked on those tools, then well and good. Then if not, then it will give you a rough idea of where to start. Okay. Then the three major or a high level paths of a data field are engineering. These are the people who build the pipelines for the data flow. Databases, SQL, NoSQL, MongoDB, all these come under the data engineering. The second is data modeling. Now, data modeling as such, when I pick this up, data modeling, it's building a machine learning model or doing something or building a model for your data. Some teams or some companies or some organizations that I work with have also put the infrastructure or the engineering side of data into data modeling. They might call that, we are working on a project and we're building a model. And when you ask them that whether it is which machine learning model you guys are using, then they would say, no, it's not the machine learning model that we are building, but we are building the pipeline. So that comes under the data engineering. So data modeling is basically creating machine learning models, testing them again and again, and deploying them into production. Then a third major topic is on data visualization. Now, Tableau experts, Power BI, Informatica, all these people are inclined towards showcasing what the output is, right? So whatever insights and information that has been extracted from the data, these guys show it to the management in beautiful, dashboards, charts. So that's what these guys are. Then I'll also deep dive into, not deep dive, but I'll give you an overview of what are the different, or what is machine learning basically. Some of you might have an idea, since I see that about 50-60% of you are freshers. So I'll explain what machine learning is and what are the different types. So right now I'll be only covering supervised and unsupervised, but there are others as well. Like you might have heard about reinforced learning, which is a hit and trial method of making a model learn. Then there is something called as ensemble learning, which is a combination of supervised and supervised. But to keep it simple, we'll just go into supervised and unsupervised learning model. And then how does a machine learning pipeline looks like? Where does it start, where does it end, and how do you maintain it? So this is from a very simple, will not go into the complex tools that the organizations use, but just to give you a rough idea of how it looks like using a very simple tool. So mostly we'll do it in Excel, and it will just give you a good idea of how things work. And it's just, if you know how to drive, you can drive any type of car, right? If you know how to ride a bike, you can ride any kind of a bike. So that's what we'll do now. I'll just, you could say, I'll teach you driving, and then you can choose your own toys or your own tools. Then the last part would be, how do you evaluate a model? How do you know your model is doing good or bad? And then what do you do after? Right? What do you do if your model is not doing good? What do you do if your model is, working really well on the test data set, the trained data set, but it's not working well on the test data set? And deployment is nothing but deployment is mostly taking real life data and giving an output, right? So if you have built a classification or a model which classifies between cats and dogs, and you see a new picture, you show it to the model. Of course, you'll not, you can show you can show it to a model if you have built a very complex system of OCRs, but in very simple terms, it would be like input the new data and get the output from the machine learning model. So that's what deployment is. And it's just as the organization increase or the levels increase, as things become more and more complex, the deployment becomes more complex. So we'll start from the very simple, very basic ones, just to help you understand what is evaluating a model, what is a machine learning pipeline, what do you mean by deployment, all those stuff. And then finally, we'll do a hands-on, right? I'll show you what are the different what are the different steps in creating a linear regression model, what is a linear regression model, and it will be using Excel, right? We'll not use any complex tool, and we'll go through all the steps in the machine learning model using an example of linear regression in Excel to keep things very simple. And yeah, in the end, we'll end with a Q&A session. So in the meantime, if you guys have any issues, any questions, you can keep putting them in the chat section. I'll take a pause in between, check these out. But if not, then in the end, we'll surely pick as much questions as we can from you guys. Okay, so brief about me. It's most of the things have already been shared by Lakshmi. So this is me. You might see some similarities in the features. So my name is Sumit. Currently, I'm working as a data scientist at PayPal. I started about two months back. Before this, I was working with AXA Business Services, and I was mostly into the ETL data engineering part, where I was leading a team of 7, and the infrastructure was quite complex, so we had to monitor it. If the data flow was not working properly, if things were bad, then get it fixed as soon as possible. So that was what I was doing back in AXA. And right now I'm with PayPal, and what we're doing is, it's mostly trying to figure out what which are the fraudulent transactions and how to take down the losses for PayPal. Overall, I have 5.5 years of experience. You could say 5.6, 5.7. And I started my career with AXA in 2017, straight out of college. I worked 5.5 years for AXA, and then recently, just 2 months back, I switched. I am now working with PayPal. Civil engineer, no coding background, and I did my marketing and operations. So I did my first line of coding in 2017. So it was in Excel, it was in VBA, and I built a few models, I automated a few of the steps. And so the first year was, from a coding perspective, it was VBA, Visual Basic. And then slowly and steadily, I moved on to Python, SQL, and so on. And I have been teaching on Upgrad as well. So it's been around 1 year, one and a half, I think 13 months or so. I teach on Upgrad, or I mentor different students. One of the universities that I work with is LPU, Lovely Professional Universities. So if you're from the north, you might know it. So Python, data scientist, data analyst, business analyst, machine learning. So these are some small courses that I take. My hobbies include, I am interested in the stock market, basically, particularly the stock options, derivatives. I do sketch a little bit during my free time, and I'm a black belt in Taekwondo. So it was 5 to 6 years back. And I also love to play cricket. So I think cricket is something that everybody loves here in India. Yeah, heartbreak today, but it doesn't matter, right? Things go on. And then finally, I hope you guys. And my road to data science is basically, I did my engineering. I completed my engineering 2014. And post that, I realized that, civil engineering was something, yeah, it was good, but something did not come up, right? Something was not really good for me there. I was not interested, or, I was not attracted towards civil engineering. So then I did my MBA from Symbiosis in marketing and operations. They took that easy way out. Marketing is something, if you're good with people, if you're good with things around you, you can talk, you can convince people. So that's what we thought, right? Then if you're good with somebody, then marketing is your right choice. And for the minors, I choose operations because interests there. And I have had a few smaller projects on the operations field. So that was another reason. But the main thing to catch her is, no, I had absolutely no coding background. Earlier that I could recall was 11th and 12th, where we learned VBA. It was not even C++ for me. I could not recall much of the coding, but I did VBA in 11th and 12th. Post that, nothing. And then I switched to, or when I started working with AXA, my first line of code I wrote in VBA, Visual Basic. From therein, I automated a lot of different manual reports, and within a span of, let's say, 1 year, I was able to save around 1.5 FT worth of work and automated everything in Excel. And you'd be amazed to know that if you are good, or if you're somebody who wants to deep dive into Excel field, VBA is something that you can really use, automate a lot of different things that keep going on in different companies. Like, for example, you can connect Excel to PowerPoint, you can connect Excel to Internet Explorer, you can download data from a website with a click of a button, you can create charts, you can create anything, you can automate all the Microsoft tools from Excel, right? You can command PowerPoint, you can command Internet Explorer, you can command all the Microsoft tools from VBA, from Excel itself, right? And then once that was done, I moved to SQL. So as I mentioned, I moved to the data engineering side, understood or learned the basics of SQL. And Python was something I started my career, or I started my understanding of machine learning in 2019, 2018. So I was lucky enough to get a data profile in AXA. straight out of college, and we had a lot of different teams sitting around us. One of the teams was for actuaries, and another team was for data scientists. And they told me what they do, and what's how is it different from other roles, what's the profile about, what kind of problems these guys solve. And that hooked me, and I was interested, and I wanted to start. And I asked them what's the best way, or how can I take my first step. So I started with this course called Machine Learning by Andrew Ng. If you have heard his name, Andrew Ng was the head of Google Brain, and right now he is an entrepreneur and a very popular name in the field of data science. I started from there. It was hardly a 4 months of course, but I spent around 1.5 years completing it. And the hardest step is the first one, right? So I did one module about 1 2 weeks, then lost interest, did something else, then started it again, did about 1.5 modules, went back. So in my third or fourth attempt, you could say I was lucky enough to get a lot of free time during the Corona lockdown. And that is when I put my foot down, saying that no, this is something that I have to start and complete. And within 4 or 5 months, I was able to complete the whole module. Now, what happened there is I took my first step, right? And I was able to understand the basics of machine learning, as in what is machine learning, how it works. So the next step was obviously how do we apply it on real life problems, real life scenarios. So then slowly and steady, I started exploring math, and then started a few courses, or did a few courses on Python, machine learning, and then mixed both of them to see how do we apply machine learning using Python. And that is when I did most of my projects. About 25 plus projects, both on supervised learning, unsupervised learning, recommendation system, anomaly detection models, and yeah, that's all. And here I am. Right. Okay, moving on. So the different. Okay, let me take a pause here and go through the chats. How does PayPal use AI/ML models to manage 712? Well, that is a good question, David. It's mostly there are different teams, and they try to build different models to track the behaviors, to track some anomalies in the payments. Yeah, that's pretty much it. Different teams work on different types of models. So all the product is different, right? There are different, or 4 to 5 different types of products, wherein for us in India, we have a very smooth system of payments, a very, very smooth system of payment as compared to US, UK, and other countries. So it becomes a little bit difficult for me right now. It's one of the challenges is to get in the role of the customer and trying to understand what their problems are. So yeah, that was one. Let's go back. Optical music recognition, world of music. Any other questions? This data is for testing. The best model. I'm just going through your. Yeah, my screen is visible to you guys, right? So I'm just going back, checking. Speaker LinkedIn link. It's already there. It's in the first few comments you'll find there. Deployment happens on test data. No, it does not. OCR. So deployment, we'll come to that. I have a few slides. So when we come to the machine learning models, we'll check that. OCR is optical character recognition, wherein take an example of the Google Translate, right? Wherein you click a picture of some language, and so you take a picture. The first step is to identify where the numbers or where the wordings are. So OCR is a bit complicated. It's 4 to 5 different models packed into a single pipeline. But yeah, of course, you can always Google things out. ML detected patterns. Okay. ETL comes in data engineering. Yes, man. Okay. So I think I've. Yes. Right. Okay, great. So now mm, everyone, so let me pick up the two one most more very frequent question that I used to get. It's like people who with uh, say not very good statistical understanding, or people who do not have a coding background, how difficult or how what are the challenges they face, right? Now first is you do not need to be mathematics experts, mathematical geniuses to work in the data science field. It's more or less if you're okay, if you're good with a very basic understanding of differentiation, differential algorithms, then you're good to go. If you can answer right now that how do you find the minimum of how do you find the minima of an equation, if you know that, then I think that's okay, that's good to start. You do not need high level or complicated statistical understanding to start as a data scientist. So the people who do PhD who actually make these different algorithms. So imagine, think of the people who created the linear regression model in Python, right? Or the people who created this Keras, the people who created TensorFlow. These are the ones who have to be mathematical genius because they actually write codes to do some complex mathematical uh, calculations. So for if you're starting right now, all you need is you should be good in maths. So understand whatever you did till 10th, right? And then 11th, 12th was mostly for you deep dive into differentiation and integration. So you just need the basic understanding of what is differentiation, or as I mentioned, how if there is a loss function, then how do you minimize the loss function? What do you need to do to, let's say if I ask you what is the minima of x square plus 2, right? You'll be able to answer. If I ask you what is the minima of x cube plus 3x plus 4x minus 5, you will be able to answer. So you should understand what's going in the back end, right? You should understand, you take the first derivative, equate it to 0, whatever is your answer, that is the point where the function minimizes or maximizes. And then you take the second derivative to understand whether it's the minima or the maxima, right? I don't think things get more complicated than this. And the second question was, if you do not have a coding background, or if you have never done coding before in your life. So I am a good example for that, right? So I never did coding. I don't have a CSC background. It's more or less if you understand the logic, if you understand the problem that you're trying to solve. So the syntax and the code can be, it's easy to get there, right? Stack Overflow is something that a lot of coders use. So you just need to understand the logic that you're working on. And if you're clear with the logic, then getting the code for that logic, it's not that difficult, right? Stack Overflow is the best friend of coders, and nobody actually memorizes the codes. You write it, run it. If there is an error, go back and check what's the error, change the error, run it. If there is a new error, then there is a progress. So you keep on doing this, hit and trial until unless you get the final good codes, right? So the different careers in data domain is, for entry level, for an analyst, SQL and Excel are two good tools, or two must good to have, not good to have, must have tools. If you're starting your career, then I would say try and pick these two tools. It's not that difficult. So Excel, if you have to learn Excel, it's more like, think of, so if you can run Excel without using a mouse, you can be called an expert, right? So the best way to do that is there is shortcuts in Excel for everything. So whenever your hand goes, or if you're working on Excel, whenever your hand goes to the mouse, stop there, look for the shortcut. So just minimize this distance. So avoid your hand, so avoid taking your hand to the mouse, and try to do everything through the keyboard, through the shortcuts. So, and then slowly you can explore the second part of Excel, which is your VBA macros. And more or less, SQL is something that right now it's very hyped. So it's a must-have tool for an analyst, let it be a data analyst, business analyst, because SQL allows you to extract the data from the databases. If you do not know SQL, or if you're not good with SQL, then you will be dependent on somebody else for extracting the data that you want to work on, right? So if you have SQL, you can download. So SQL is a language that helps you communicate with the databases. So if you can communicate with the databases, you can download the data on your own. You don't need a different team, right? So SQL and Excel are two must-have tools for an analyst if you want. So somebody who wants to explore the field of data engineering, the back end, the ETL part, wherein you create the pipelines, that this is the raw data and this is where it will go. Once, so imagine thinking, or no, just think of the rainwater. Okay, rainwater harvesting. So data engineers could be called, can be called as the team who does this, or who creates the pipeline which captures the data and right to the point wherein you open your tap, fill your glasses, drink water, right? So the data engineering team is in charge for everyone else in the organization to get their data. So if you want to explore this, if you're interested in building the pipelines, building the architecture behind the databases, then yeah, you need an understanding of SQL and NoSQL. So SQL is to interact with tabular data, which is in the form of rows and columns. NoSQL is a language to interact with a different type of a database, right? So a SQL database is where you have rows, columns, it's a tabular form. So NoSQL, or there are other different or other type of databases which do not have this tabular form, and you need NoSQL to interact with them. But it's not a must for data engineers, because there are some organizations who do not use NoSQL, who only use SQL. But if you're interested in a company, if you're interested in a profile and they want NoSQL, so it's up to you, right? And big data, Hadoop, all these are the tools that come under the data engineers. So big data is nothing but it's where you have a huge inflow of data on a regular basis. That is big data. So your normal queries will not run, or they will run, but it will take a lot of space, a lot of time. So big data or BigQuery was specifically built to BigQuery was specifically built to interact with huge databases. And in the backend, there are some optimization algorithms, some hashing that's done so that it's easy to extract the data. So that's the only difference, wherein the query that you'll write will more or less be the same. But in the backend, if it's big data, then there are a lot of different optimization algorithms that run so that it's easy to extract the data. The next field is machine learning engineers, right? So machine learning engineers are the people who, once they get the data, they create a model on the data that has been given to them by the data engineers. So once you have the data, what do you do with it, right? A machine learning engineer will create a machine learning model out of it. And what kind of model will he use, and how will the deployment be done, and how or what kind of data set will the model learn on, what would be the parameters, what would be the hyperparameters, so all these questions are answered by a machine learning engineer. So there's also, so these are not the profiles, and there, so data engineering might be a profile, but within it, so there's, there's a team of data engineers, let's say there are 6 people, 8 people of data engineers, all of them might be doing something else, right? All of them might not have the same skill set. Similarly, for machine learning engineers, somebody might be very good in building a model, whereas somebody else might be very good in deploying those models and supporting the production, right, which is known as your ML ops. So ML ops are different tools, different skill set that is required, but it also comes under machine learning engineers. So the tools for them is Python, R, There are others as well. You could use Octave, you could use MATLAB, and the final or another set of bucket of experts are the visualization experts. So Power BI expert, Tableau experts, these guys are really good with charts. They know which chart to use when, plus what kind of colors, and they can work in a direct, they can work directly with the data engineers, right? A data engineer creates the pipeline, and then Power BI and Tableau can pick up data from the databases and use it for visualization. The best part here is once the data refreshes, your charts refresh on their own. So you just need to create the dashboard once, and then you just need to maintain it. So if the data in the database refreshes, your Power BI and Tableau refresh. So yeah, these are the high level or a big umbrella of different types of work, different types of profile that the people working in the data field can have. So depending upon what your interest is, if you want to work around with charts, if you love dragging, dropping rows here and there, creating beautiful charts out of them, beautiful dashboards, then Power BI or Tableau is something that you can explore. If you guys want to, if you guys are more interested in building models, building futuristic machine learning models, then Python is something that you need to learn. And then how do you use Python, or what are the different libraries, sklearn, TensorFlow, Keras, how do you use these libraries to create models? Okay. And for data engineers, it's building the infrastructure of the data. So how does data flow from your data warehouses to different data retail stores, you could say, and then how do the consumers extract this data? So database engineers, database administrators, and data engineers are all these people who are responsible for the infrastructure of data, the pipeline of the flow of data. And analysts are mostly people with an entry level or who want to start their career in the field of data. So the better you are in SQL and Excel, the higher is your probability to excel in the data field. Okay, as an entry level expert, you could say. Okay, going back, let me just check if you guys have any questions, and then we'll move on to the next slide. Can you raise some example and use cases of real-time data path in ETL? So Rithi will not be covering ETL here, but I can give you an example. I mean, in the last, if you have a few minutes, we can check this, or else you can always connect with me on LinkedIn, and we can maybe drill down your question a little bit more. It's a bit vague right now, but yeah.
Sumit, sorry to interrupt you, but there are
Yes.
few questions under the Q&A section. You can go through them also if possible.
Okay. I was picking that up. Sorry, my bad. Got it. I was opening the wrong. Okay, so David says keen to understand managed account verification security measures from experience. This is very specific, David. Plus, I am not representing PayPal right now, so we can come to this. We can come to this later. Okay, the case scape is a software suite of protocols, quantum communications, get for quantum. Yeah, it is. It's not just beyond, but it's infinity, beyond infinity. But yeah, we can connect on this later. But for the scope of this particular webinar, this is not in the scope. So how do you get an internship or fresher job in data science? Okay, how important is time series for data science? Any other platform apart from Kaggle to uplift the coding skill in data science? Okay, so for internship or fresher level job in data science, all you need to know is you should be good with stats. Of course, the first and the foremost, the basic steps are creating a good CV, creating a good resume, applying to jobs, getting in touch with people, networking. So that's the first part, right? So given that you land an interview, what do you need to do then? What do you need to showcase, or why are you a good fit to start your career in fresher, as a fresher in the data science? So first is, if you have a project under your belt, which you can explain. And when I say a good project, it's not working with these iris dataset, ms dataset, the most common datasets. No, not these. But if you can get your hands on something, maybe pick up a dataset from Kaggle, pick up a dataset from Analytics Vidya, go through it, clean it up, because cleaning a dataset is the most important part. And this is something that you miss when you are doing, when you opt for some courses, certain certifications online. The most important or the most raw job in the data field is getting the right data, which is about 65% of the whole hassle that you guys that we guys face. So once you have this, maybe create a project, have a good understanding of statistics. And since data science is a huge field, right? So maybe narrow it down a little bit, narrow it down to machine learning engineer roles, narrow it down to maybe data engineering roles, visualization roles. But it would be better to have, let's say, one project. Then the next is a good understanding of the different types of model. What is machine learning? One, which model to use when? What are the pros and cons of linear regression? What are the pros and cons of logistic regression? Why should you use SVM? And why should you not use a logistic regression? So these are, of course, not for fresher level, but maybe as you keep on going ahead, so you need to have a better understanding of these. For a fresher, I think a good understanding of statistics, machine learning basics should be good to go. And it all depends on your ability to talk to people. So for internship, for a fresher, you need to focus more on the networking and the soft skills, and a little bit of, I would say, what, 60-40, 60 soft skills, 40 technical skills. And then as you go ahead, soft skills would be there, right? Soft skills will not go down. And then just go ahead and improve your technical skills. So how important is time series for data science? Time series is something, it's a type of model, right? If your data demands, or if your data is a time series data set and it demands a time series analysis, then of course you cannot apply logistic regression there. But if your data is something else, it depends on what kind of problem is your organization or is your team trying to solve. So time series is a type of model, right? It comes under supervised learning, and it is a type of model. And its importance depends upon what kind of problem you're trying to solve. Okay. Another platform for Kaggle. So you have a lot of platforms. Like Analytics Vidya is one of the platform. Then if you want to increase your coding skills, Lead Code is something that you can explore. And so Kaggle, Analytics Vidya, Lead Code. Yeah, I think that's it. So overview are these. You can get majority of your projects or dummy projects from these sites. Will these slides be shared with participants? I don't know. It's up to Lakshmi. If she wants these, I can share it with her. Okay, you know about the freelancing career of data science and machine learning. What are the skills and how to hunt for the projects? So for freelancing, for me, it was like I had my CV, I had my resume out there, and the people from Upgrad contacted me regarding a session if I was interested to teach. So it's more or less be prepared and put your resume out there and just do your best, whatever you can do from your end. And the things which are not, which are not in your hand, just leave. Don't be stressed about those. So right, you have independent variable and then you have that some dependent variables. So the variables that are dependent on you, make sure that you take good care of those. And the rest of the variables which are not in your hand, you cannot do anything else, right? So be prepared and just put yourself out there. Hunting for project is, think of the different types of problems that different companies are trying to solve. So imagine so think of what kind of problem would a company like Walmart face, or what would the data science team, or what would the data team in Walmart, or what will be the or what kind of problems will they solve, right? Walmart is one of the examples, but you can think of any company, think of the type of problems that they are solving, right? So it could be in any domain. So the best part of being somebody in a data field is you are not restricted to domain, right? Like for example, if somebody works in a highway construction project, so they are, if they want to switch to healthcare, right, it's difficult for them. But somebody who works in a data for healthcare will not have, or he might find it easy, or might not find it as difficult as somebody else, because the data is the same. It's just the number X might tell you something in a healthcare domain, the data, or the number X might tell you something else in a construction domain. But if you're good with data, if you have people who have good domain understanding, if you check with them, then it's not a data or somebody working in the field of data can fit into any domain. So that's the best part. So hunting for project, just go through Kaggle, go through analytics with their different hackathons, and see what kind of problems are they solving, and just get your hands dirty. So what are the main difference between deep learning and machine learning? So machine learning is, I would say deep learning is more inclined or heavily inclined towards neural networks. So for machine learning, for more complex or more detailed, or yeah, I think for most complicated projects, you would use deep learning. For example, if you're working with image data set, if you're working with videos, if you're working with audio visual data sets, so a simple legacy machine learning model might not work as good as a deep learning model. So whatever models are built in an artificial system or in an artificial intelligence system are deep learning models. So machine learning might be a small part of it, but it's more or less the more complex the problem is. So you are more inclined towards deep learning, and machine learning is for simpler. So if you start using neural networks, convolution neural networks, GANs. So GAN is something, generative adversarial networks, which is a type of machine learning model. So all these are examples of deep learning, and they are complex. Machine learning model would be as simple as your linear regression, logistic regression. So these are all a part of machine learning. AWS or Azure required for data science. So cloud is, so cloud has nothing to do with data science. It's a tool, like, so you can do the same things that you're doing on your or a data engineer can do it in SQL, and a data engineer can also do it in the Google Cloud. So it's just where your data is in the backend. So Azure, AWS, GCP, they are more or less, they are, think of it as this way, they are different roads that take you to the destination, right? But data science is the vehicle that you're traveling. Okay, yeah, you might be traveling in a bike, you might be traveling in a car. That is the data science, and the path or the road is the AWS, Azure, or GCP. So a cloud is basically, it's your system, right? It's the physical system that I have here. So I have my laptop here, so it's a physical system. But instead of storing my data in this laptop, if I choose to store it in the cloud, but that is also a laptop, right? But it's a huge space that is available somewhere. Google created it, put it somewhere, a huge acres of RAM, CDs, and all this stuff. So cloud is something different, and data science is something different. Data science can be done in AWS, Azure, GCP, anywhere. Okay. Okay. Is there a specific stats, probability course, to freshen up on these topics that are good? So Francisco, I would say, I said I don't recall some particular stats, but here's what, some particular course, but here's what you need to understand. So just search for them in Google, right? Search for basic statistics. You should know what is normal distribution. what are the different types of hypothesis testing models. So this is for hardcore statisticians, right? So that's different, a little bit different from machine learning or data scientists, and they are more or less on the research side. But for this, for the statistics and probability required for machine learning or for a data scientist are not that complex. If you're good with normal distribution, if you are good with the Bayesian theorem, or as such the basics of probability, right? Then you're good to go. But if you want to deep dive into as from a statistician point of view, then there are some, for statistics you can start with the different types of tests, p-test, t-test, chi-square test, and a few other tests, hypothesis testing models from a statistics point of view. From a probability point of view, you should know what a Bayesian what naive Bayes theorem is, and what is the probability distributions. And yeah, I think that's pretty much it. And then depending upon, once you go through these topics, then whatever you find, you can deep dive on them later. Good specific projects in Kaggle, a simple platform that you can recommend that are free where someone starting data science can. Yeah, so yeah, as I mentioned, Analytics Vidya has a lot of hackathons, same as with Kaggle. So you can just go, there are some hackathons that go on throughout the year, which are free of cost, which are just for practice. So just go through them, pick up the project that you want to get your hands dirty on, and yeah, just go on with it. First is try to see, we'll come to this, we'll come to the machine learning pipeline, wherein we can discuss more. Okay, which project should you put in resume? It depends, right? So your resume, so the best practice is to change your resumes depending on the different types of profiles that you are applying for. Okay, so you might have the skill set for a software engineer, you might have the skill set for a machine learning engineer, and if you decide to share the same resume in both, then it might be good. But if you decide to highlight in the same resume, if you decide to highlight your software engineering projects for the software engineering profile and the machine learning project for your machine learning profile, that would be good, right? But let's assume you're applying for a data analyst job, and what kind of projects you need to have there. You don't need to have very hi-fi projects there. If you are somebody who's good with Excel, if you're somebody who has worked on the SQL, and what are the different joins, what are the stored procedures, and you have a good understanding of how to create views and how to create stored procedures and how to extract data from SQL, and inserting different joins, as a data analyst, that should be enough. Okay, and if it is in your fingertips, well and good. Second, if you're applying for a machine learning engineer, or if you're working or applying for a data scientist role, so you need to have certain, so the basic projects like the iris data set, working on the housing prices, then working on the MNIST data set, these are very common among data scientists, these are very common among machine learning engineers. So it will not help you differentiate yourself from the others. What I would say just is work on some, like one of the projects that I worked on was an audio classification project, right? It had 10 different genres of songs, and each genre had 100 different songs, and each video clip or each audio clip was 30-second long, right? So then extract, how do you convert this MP3 data into a tabular form? So there is a library in Python, which is Librosa, and Librosa is used to extract features from these from your audio clips. So if you recall, back in your 8th, 9th class of physics, audios are nothing but they are waves, right? So wavelengths and frequencies and your zero crossing rate. So how many times does your wave cross the 0 bar in 1 second? So that's one of the features, right? How Are the waves concentrated? So all these are your video audio features, which is extracted, and a number is attached to it by Librosa. Librosa is a library that you can use. So your first step would be to convert the MP3 into a tabular data. Second, check this data, identify, you can do a feature engineering if you want, identify the best features, and then create a model. Maybe have 4 or 5 different models, check the score, which model is performing good, which model performs better as compared to the others. If it is a classification model, let's say you start with a very simple logistic regression. Okay, then maybe you move on to SVM. Then you SVM is a support vector machine. Then you might also think of putting in MLP, which is your multi-level perceptron. It's an example of neural networks. And if you want to make it a little bit more complicated, you can also choose to have maybe a convolutional CNN or an RNN, make things interesting, to make things more nice for your resume, right? So once you have done this project end to end, so you can highlight it. So this is an example. You can pick up any other projects. You can just make your hands dirty. Think or pick up a project which you know nothing about, and then start Googling things, start working on it, pick the brains of some of your mentors. And then once you are done with it, you will be really happy, and it would be a good addition to your resume. So yeah, that's how you can pick projects. Okay, so all your questions you can put it in the Q&A section. Okay, so I'll not. What is machine learning? It's basically, think of yourself. Remember, go back to your childhood and try to remember how you learned the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. How did you learn the alphabets ABCD? So it was every day, right? Every day you saw the picture of the alphabet A, and in your mind you associated it with A. And similarly, you learn words. Similarly, you learn languages. So that's what, or that is how a machine learns, right? The more data it has, the better would be its understanding. So there are two types of machine learning models, which is supervised learning and unsupervised learning. And as you can see in the difference here, a supervised learning is when you have labels. Okay, and an unsupervised learning is when you're just given a flat data set with no labels, and you want to identify what is the similarity between the different data points. So the same data set, I've used the iris. This is the iris data set here. And if it has the labels, what you will do is you will try and segregate these labels. And then once a new feature comes to you, you will know whether it is iris setosa, virginica, or versicolor. But what happens in unsupervised learning? In unsupervised learning, you don't have labels. So what you do is you try to club the data points which are similar to each other together. Now, one of the examples would be so when you go to Google, when you search for certain things, yeah, you get a lot of different web pages, right? So if you are searching for one topic, you will receive articles, or you'll receive web pages related to that particular topic. So in the back end, whenever somebody creates a new website, the algorithms check what type of website, right? So there's no human that sits there and who can just see, oh yeah, this article is on cricket, so it should be on cricket. This article is on football, so it will go in the sports section. This article is on the politics, so it will go there. So it's not a human, right? So it's a machine learning algorithm that runs in the backend. So examples of your supervised learning are regression, wherein you are trying to predict certain values, continuous values, like for example, housing prices prediction. And classification is an example of, let's say you have thousands of different images of cats and dogs, and you're trying to classify whether a new image that comes to you, whether it's a cat or a dog. So that's classification, which is not continuous. It's different buckets. And regression is continuous in nature. It's you are predicting the numbers, continuous numbers. For example, housing prices, it could be what would be the rainfall, predicting the rainfall. And unsupervised learning is more or less, clustering is a major, it covers about 80 to 90% of unsupervised learnings. Clustering is you cluster the data points together. The data points which are similar to each other, you cluster them together. And the data points which are the distance of two data points in space, the closer they are, the more likely they are to be together. And the farther they are, the more likely they are to be not together, right? So PCA and dimensionality reduction are two other algorithms for unsupervised learning. PCA is your principal component analysis, which can be used for feature engineering. PCA gives you a good idea of, if you have 50 features in your data set, then which out of these 50, which are the most important features for your data set? And PCA will give you that. And dimensionality reduction is, if you have 100 features, if you have, let's say, features are these: the sepal length, sepal width, petal length, petal width, all these are the features, right? For a housing prices, it could be a number of the area of the house, the number of bedrooms, the living space, availability of parking space, and all. So these are all different features. Now, if you are somebody who's working as a data visualization expert, if you're a Tableau expert, if you're a Power BI expert, then you cannot put all the features in one single plane, right? A 2D, a scatter plot is of two different dimensions. You cannot create a scatter plot of 10 different dimensions, 10 different features. So in those cases, you use a dimensionality reduction algorithm. So how it works, it's basically, if you have a 2D space, you create a line in between. And if you go back to your school days and remember the projection of a point on a line, so that's the basics behind the working of your dimensionality reduction. So if you want to convert a 2D into a 1D, basically what you're doing is you're converting a plane into a line. So have a line, project all the points of that plane onto that line, and pick that line, check it. So you have a one directional 1D data. So that's how your dimensionality reduction works. It's good if you have 10, 15 different features, you put it down to two different features, you can create different plots, check it. Okay, next is, how does a machine learning pipeline looks like? What do you do in a machine learning model? The first and the most important part is collecting the data and getting the right kind of data for your analysis. The second part is, once you have this, of course, the data engineers, as you might have thought, the data engineers are the people behind this, more or less, depending upon where you get the data from. If you're getting it from the databases, then yes, you have to work in collaboration with the data engineering team. But what we are interested in is this part, the data modeling part. So first question is, what is the problem that you're trying to solve, right? What is it? Whether you're trying to, let's say, reduce the cost, or you're trying to maximize the profit, or you want to check, you want to minimize the seller risk, you want to minimize the fraudulent transactions that happen. So that's the problem that you're trying to solve. So define it. Then second is, do you have the data for that problem, right? Or what kind of data do you need for that particular problem? So get in touch with your data engineering team, with your database team, and extract the data that you require for your analysis. The next step is evaluating, or what would be your evaluation parameter. Let's say if your error is less than 90%, or if your model is correctly able to predict 98%. So that is what your evaluation is. So you will create a model which gets 98% accuracy. So what will, or when will you stop, right? That's, you define that. The next is, what are the features that you'll be using? So feature engineering is a very important part. How do you deal with missing data? If there are, say, 10,000 different features, how do you choose the most important features? Of course, if you have that bandwidth, you can work with all the 10,000 different data points, but it will just be computationally expensive and it will make no sense. So feature engineering is a very important part of creating a model. Finally, in your fifth step, you create the model. Which model you create? Do you use an SVM? Do you use a logistic regression? You don't know. So why not use both, right? So choose the models that you want to use and create a rough model, or use all these models to create a rough accuracy, or train all these model on some rough data points. Let's say you have 4 different types of model, you have the same data set, put it through all the 4 models and see whichever is giving you the least error or whichever is giving you the most accurate results. Pick that model and then start building on that. Okay, now machine learning is a very iterative process. Okay, so nobody reaches their desired successful answer after the first iteration. So once you're done, once you've created a very simple, once you've created your model, check what is the accuracy. If you have 98% accuracy, or if you want to stop at 98% and you get 85%, so go back, see what needs to be changed. Do you need more features? Do you need more complex model? We'll do a hands-on here, right? I'll pick up a housing pricing data set and we'll do it in Excel and we'll see how it works. So you need to have one parameter or one number that will define your success. And all your iterations, everything that you do with the data for the data should, you should see how this number is changing. If the number goes up, then whatever you're doing, whatever changes you're doing to the data is good. If the number goes down, so depending upon, let's say if it is accuracy, if whatever changes that you have done, if let's say you have normalized the data, okay, you have used feature engineering to create some additional features for the model, run the model, see what is the error, what is the accuracy. If the accuracy has gone up, then whatever changes that you did was good, keep it up, keep doing that. But what if the change that you did, your accuracy went down? So no, that's a bad change. So have this one number, and whatever change you do to the model, come back and check this number. If the number goes up, if this number is accuracy, if it keeps going up with whatever changes that you're doing, then the model that you're building is good, right? And then the final step is deployment, which is nothing but the parameters that you have after the model has learned. How do you use those parameters to predict on some new data that is coming in? We'll see this, we'll do a hands-on and we'll see how it works. So what I have for you guys is I have a housing pricing data set. So what we'll do is the first step is we'll break this data down into training set and testing set. The training set is the one where you train your data on, and the test set is where you evaluate your model to see. You have in the test set, you have both the answers, you have your predicted answers and you have the actual answers, and then you just compare your predicted results to your actual results and see where it goes. So training data has the labels, testing data also has the labels, but training data labels are used to train our model. And once we have this parameter, once the model is trained, you use this parameter on the test set to get your predicted answers, and then you compare your predicted answers with the actual answers and see how well your model did. Okay, so that's what we will do. It's time for hands-on. Okay, so this is the data that we have. Now what I'll do is I'll use this raw data, and then I'll explain to you one important feature engineering step, which is normalization. There is something else, which is standardization. More or less both of them, the working is the same, why we do it is the same, but how we do it is different. So for normalizing a data, we use the mean and the standard deviation, and for standardizing a data, we use the maximum and the minimum values. Okay, so this is what our data looks like. So this is a housing pricing data set. So I've tried to keep it minimum. What we have here is the lot area, what is the overall quality, what is the overall condition of the house, in which year was it built, What is the basement area? What is the living area? How many total rooms above the ground? What is the garage area? And then what was it price? What was the price? You see, we have around 1460 different data points. So the next step would be to change this into a test and a train set. So ideally, you can take anywhere between 70 to 80% as your test or as your training data set, and the remaining as your test data set. So when you go through these models, you might also come across another data set, which is your validation data set. So it depends on you. Now, how it works is the training data set is used to calculate the parameters. So these are the parameters, right? The lot area, the overall quality, overall size, year built. So all these are the parameters. So your model learns on these parameters using the training set. Then you have something called as a cross validation set. So with the parameters that your model learned in the training set, the hyperparameters are learned in the cross validation set. Now, what is a hyperparameter? So hyperparameters are the parameters of the model. So the hyperparameters of a support vector machine would be different. The hyperparameters of a logistic regression would be different. Now, both of them can be used for creating a classification model, but the hyperparameters for both of them are different. Now, what hyperparameters is, think of it like, let's say in a linear regression, there is a learning algorithm, right? Or a learning parameter, which is known as alpha. That is the hyperparameter of your linear regression. So for a neural network, it could be your drop rate. Now, what drop rate is, in a neural network, you might, you have a very good chance that a neural network might overfit to a data. Now, what overfitting, underfitting is, I will come to that once we have created this model. Okay. So the first step is I've taken about 1000 points, right? Yeah, 1000 points as a part of my training set, and the other 1000 as part of my test set. This. So a linear regression model is very simple. It's based on the equation of a straight line, right? Y is equal to mx plus c. Let's come here. So y is equal to mx plus c, right? Y is my label. So in this case, my sale price is y, right? M is the slope, x is the parameter, and c is the constant. Now, if I have to convert this into this, I'll say y is sales price, and I can say sales price is equal to lot area into the slope of lot area plus the overall quality into the slope. So it will look like this. It would be y, which is your sales price, is equal to m0x0 plus m1x1 plus m2x2 and so on. And these are the slopes. So m0 is the slope of the bias. Now this is an additional column that I've added. So if you go back and in an equation of a straight line, y is equal to mx plus c, you can also have y is equal to m1x1, or let's say m0x0 plus m1x1, correct? So in this case, c, the constant, the bias, I've taken it as m0x0, and x0 is a bias that I'm adding from my end, which is 1. Okay. So the equation of this line would be sales price is equal to the bias into its slope plus lot area into its slope, overall quality into its slope. So it's like this. What I'm assuming, or what I'm taking, is 208500 is equal to m1, so m0 into 1 plus m1 into the lot area plus M2 into 7, M3 into 5, M4 into 2003, and so on. Now, what does a model work, or how it works? What I'll do is I have Y, I have X. So I'll use the training set, use the train set to learn M and C. And once I have trained my data, then use M and C to predict on new X. Right. So that's how a machine learning model works. So you have Y with you, and we have the X. X is the feature with us. We will use a model to understand M and C. So once I have M and C with me, once I have the slope and the intercept with me, I can use this to have a new Y for a new X. Right. So that's how your machine learning, or that's how a linear regression works on a very basic, very simple level. Right. So let me delete these and we'll start from the beginning. Right. So this is how my data looks like right now. So what my prediction is, let's say, in order to start, I give them some random values. Of course, I'll not start with 0, because then there are chances that my model will not go anywhere, right? So let me take the random values between 1 and 10 to start with. And my prediction would be a matrix multiplication of this. And since I'm doing since I'm doing a matrix multiplication, so I need to make sure that my rows or the dimensions of my array are good. Right. So what this is, it's nothing but it's 1 into 3 plus 8450 into 9 plus 7 into 2 plus 5 into 3 and so on. And this is what I have with me. Let's do it for all. And these are my predictions, my initial predictions. Okay, let me fix the parameters. I don't want them to keep changing. Right. So this is my prediction, which is very poor, very bad, right? Because I've not used a model yet. Now, what is the error? The error parameter that I'll use is, let's say, a root mean squared error. Now, what a root mean squared error is, it's the square of the errors at this minus this, the square of that. Let me have this for everyone. And the root mean square error is nothing but it's the square root of the average of the sum, or average of all the errors. So this is my error right now. So out of all the predictions that I'm making, I am 1,34,337 units here and there. So you see, it's very bad, right? Now let's go ahead and see how we can minimize this using Excel. So in Excel, you have something called as solver. So if you go to data, you can see data analysis and solver. By default, these are not present. So once you download or install MS Excel, and if you go and open data, you'll not see these. So in order to have these, just go to file, options, and you need to add in add-ins, and add this solver add-in analysis and this. So manage Excel add-ins, click on go, and just click on these, click OK, and you should be able to see these here. Right, then let's come. Click on solver. Now my objective function is this, root mean squared error. Now what I want to do to this is I want to minimize it by changing the variables, by changing these. Okay. And there are various solving methods. So GRG non-linear is to solve the non-linear. Let's say if you want to find the minimum of a quadratic equation, right? Then you will be using a non-linear solving method. A simplex linear method is a different case. It's used when you have different thresholds, right? Let's say you want to maximize the prices with a limited number of seats on a train. or on an airplane. So you have different lines, different equations. So wherever these lines intersect, those are the points which are overlapping. So it's a different type of problem. That is where you use simplex linear. But for us, since these equations are quadratic, and we need to minimize the quadratic equation here in this case, so I'll be using a GRG nonlinear and nothing else, but I just click on solve, and let's see what we come up with. Keep the solver solution. Okay, right. So this is what my model has learned. It has given me a new parameter. So it says with these values, wherein my M0 is 2.61, M1 is this, I get the minimum error of 44,747 units. And that's all. Okay. The next step is evaluating your model. So how do you know that using this particular model, you'll not go down, right? Your error will not go any below this point, because if it was, then your solver would have gotten that result. Now, using this solving method, what I'm getting is, let's say M4 and M7 are 0. That is 0, 1, 2, 3, 4. So the year, the age, and the number of rooms available above ground, they don't have any impact on my price. This is what I am getting from this case, from what my first solver did. But this is a raw data, right? I've not done any feature engineering. I've not done anything to this. So instead of year built, I could have had the age, which would be 2000 or 2022 divided minus 2003. So it will give me the age. So instead of using the year, I could have chosen to use the age. So choose age, see what is error in that case. If error goes down, well and good. You need to make that change. If your error does not go down, then let it be, leave it as it is. Okay. Now let's go back to our training data and see how we performed on our training data set. So my predictions are matrix multiplication of this with the parameters that I learned. So these are my predictions. So you see, I'm predicting 13,000, sorry, 1,33,000, but it's the actual price is 82. I'm predicting 77,000, but the actual price is 86. So the error, I'm still making the error of 53,807 units. And this was the best. Okay. This was the best solution that my linear regression model can come up with. Okay, then now there is something called as feature engineering, right? In the first case, we did not do any engineering. But the best thing that you should do is from a machine's point of view, right? The lot area is in thousands, but the overall quality is 0, 1, 2, 3, it's just 10. So it is normal for the model to give more weightage to the lot area rather than the overall quality. So in order to avoid this unwanted bias in the dataset, what you do is you do a normalization or a standardization. Now in our case, what we'll do is we'll do a normalization. Now, how do you normalize the data? So let's say I want to normalize the lot area. What I'll do is I'll take the average and the standard deviation. Mean is nothing but it's the average of this, and standard deviation is the standard deviation of this. And now I convert all these values. So instead of 10,106, it will be 10,106 minus its mean, let me fix this, divided by the standard deviation. So you see, this lot area has now been converted into another distribution with mean 0 and standard deviation 1. So similarly, convert all. So you convert overall quality, this, year bit, everything. And this is what we have done in our next data set. So this is the same training data, but now it is normalized. And let's see what's using this normalized data, what are the changes that we get. Okay. So what I've also done is I have divided the sales price by 1000. So instead of, so this is 208.5 thousand, just to keep things a little bit simpler. Okay. And everything else is the same. Now I did the same thing. My root mean square error is the error of my prediction minus the sale actual price, square root of that, and then a sum of that, and the square root of the whole thing. Right. So when I changed my parameter, when I normalized my parameter, you see in my earlier cases, M4 and M7 were having 0 weightage, but in this case, it's not the same, right? The weightage, the weights changed, and using these new weights, the error that I'm getting is 36,000. In my earlier case, it was 44,000, and now the error that I'm getting is 36,000. And I've minimized this, it cannot go below this. Now let us apply the same, apply these new parameters to the test set that we have. So the predicted is again the matrix multiplication of these values with the new parameters that I've learned, with these new parameters. And what is the error now? The error that we have is 44,000. What was the earlier error that we had in our test data set? It was 53,000. So you see, after just normalizing the data set, I have removed the unwanted bias that we give to the model, and the model has learned in a better way. Okay. So you have two scores of training set and testing set. So how do you know whether your model is overfitting or underfitting? Overfitting is when the line or your model tries to match each and every data point in space. So this is right here. So this is a case of, this is what your regression line looks like, the best fit line. Now, if instead of this, it was a curve which went through each and every point, right? That would be overfitting. Now, if underfitting is when your model is it's rigid. Now, if you give new data to your model and it says no, this is the answer. When you give new data to your model, it says no, this is the answer. So when your model is rigid, that is, it is underfitting. And when your model is very flexible, whichever data you give it, it says yes, I like it, this is the answer, then that is an overfitting model. And how do you differentiate, right? Because this is a 2D, you can plot it and see. But when you have hundreds and thousands of different features, you cannot plot them. So a best way is to compare the scores of your training and test set. Now, if you are overfitting, you will have high train and low test score. If you are underfitting, you will have low train and low test score. And then once you know whether you're overfitting or underfitting, you can work accordingly. In a linear regression model, if you are, obviously, if it's a one, if it is a first order linear, if it is a linear model, then you will not overfit, right? Because it's a straight line. And the only scenario is you can go up from there. So if you see that you're underfitting your data, what you can do is you, instead of using a linear regression, you can use a polynomial regression or a second degree. You can create some new features. So instead of using the lot area, you can use the lot area square. So let's say if you had just two cases. So instead of using y is equal to m0 x0 plus m1 x1 m1 x1 plus 2x2. So this is the first degree. If you want to convert it, you can create new features. And what these new features would be is, let's say m0 x0 square plus m1 x1 square plus m2 x2 square plus m3 x1 x2. So that's a second degree. And you can do the same thing. You can check whether your error has gone up or down. So this is, you are creating new features, or you're converting a linear regression to a polynomial regression, right? And that's how, so these are the steps how a linear regression works. Now, of course, if you are doing this in Python, you don't have to do anything. You just have to import the library from sklearn. So you say import linear regression from sklearn, and all you do to do is model is equal to linear regression, then model dot fit x train, y train, and then model dot predict x test, and then you can evaluate, right? So that's all. With these 3 to 4 lines of code, you have built a linear regression model in Python, right? So it's building a model in Python. It's not difficult. It's hardly a few lines of code, but what goes on in the back end and the front end, depending upon how your model performs, what are the changes that you need to do, that's the main game. So the better you are there, the better you are at understanding how the model works and how to tame your model, you could say. The better you are at taming your model, the better machine learning engineer or ML scientist you are. So a very small example of a linear regression. This is how it works. And this is a machine learning pipeline. And for deployment part, you see how to deploy this is, you can have an Excel sheet with these model scores. And basically this is what we did. Okay, this was our deployment. Let's say these are the new values that we received. And I just did a matrix multiplication of the weights that I identified with the new X and the new features that I received. Of course, the prediction that you have will not be accurate. Okay, so you should always give a range of prediction that you are about, say, 80% or 90% confident that the prediction will lie between X and Y. So you never give an accurate prediction. Okay, you always give a range of predictions. And this is how your regression works basically. So I randomly with the random weights that I gave, I created a random line. And then depending upon how far each point was from the predictions, what I'm doing is I'm just minimizing the distance of these points from the line. And the line from where this distance is minimum is my best fit line. As simple as that. Any questions? Is it possible to switch from data visualization to data scientist? Yes, of course. There is no, so the possibility is always there. The possibility to switch from anywhere to data science is there. It's all about the road that you want to take. Okay, you should know, or you should just understand the path, or what it is needed, or what domain are you more interested in, and then check out what is required, what you need to know, what are the prerequisites, what you already know, what you need to learn, and then go on and check out different courses, certification, or Google things out, as simple as that. What other parameters do we use to evaluate a model's accuracy? It depends. Like if it is a linear regression model, the one that we have used in this particular scenario was the root mean squared error. But you have certain other evaluators as well. You have something called as mean absolute error. You have something called as mean absolute percentage error. So whichever is good, whichever model or whichever parameter that you want to choose for evaluating a model, if it is a linear regression, if it is a regression problem, I would say stick to RMSE. RMSE is pretty good, right? But it depends on you. You can choose to use mean absolute error, or you can choose to use something else. Now, when it comes to classification problems, in classification problems, accuracy does not work that good, right? If you are just interested in knowing that out of the 100 tests, how many or 100 results that your model gave, how many of them were accurate, in some cases it might work, but in certain other cases it might not. So there's something, or the best way is a classification report, or which is your confusion matrix. So you create a confusion matrix, then you can go ahead and you can Google these things. Just write it down, because I don't want to take much time of others, right? So confusion matrix is used to calculate the precision and recall. Now precision is out of all the predictions that your model made, how many of them were correct. Okay, then recall is out of all the answers, or out of all the predictions, or out of all the actual predictions, how many did your model get correct, right? It's more or less like accuracy, but precision and recall give you a better understanding. And then when you combine both into an F1 score, so F1 score is nothing but it's twice precision into recall divided by your precision plus recall. So it combines both your precision and recall. So if you're working with a classification model, I would say use precision and recall as a model evaluation parameter. If you're using a linear regression or any regression model for that matter, use the root mean squared error. But yeah, it's not a hard code. If you want, you can change it. You can choose to use something different. So what is the hyperparameter? So hyperparameter is something, it's the I could say it's the parameter, or it's the functionality of the model, right? It's the features of the model. Now a linear regression that we use in this case, a hyperparameter in a linear regression is alpha. Alpha is it's the learning coefficient. Now in our case, since we use the solver, so we did not have to define any alpha, or we did not have to define any learning rate, because the method that we chose to get to the minima was different. But if we choose to use a gradient descent method to get to the minima, so a gradient descent has something called as a learning rate. A learning rate is the hyperparameter of your linear regression model. And similarly, for a logistic regression model, you may have some different hyperparameters. Like for SVM, support vector machines, you have different hyperparameters. For neural networks, it could be on the different level, the different layers that you have, what is the drop rate, because a neural network is more likely to overfit the data set. So what you do is you keep dropping some random neurons from the hidden layers, and then you check. Okay, so on the hands-on regression model, what determines how you build the equation used for the prediction? So I use the equation for a straight line, right? So y is equal to mx plus c is the equation of a straight line. Mx into c is not, it's not an equation of a straight line. So what I'm trying to do is I'm trying to segregate. So in a two-dimensional space, like in this, it's a two-dimensional space here. I'm trying to add, or I'm trying to predict a line. Okay, So therefore, I need an equation of a line. Y is equal to mx plus c is the equation of a line. Now the equation of a hyperplane would be y is equal to m1 x1 plus m2 x2 plus m3 x3. So it's a line is in 2D. It's a two-dimensional. A hyperplane is n-dimensional. Okay, but the working is the same. So therefore, the equation for a linear regression is the equation of a line that we start from. Y is equal to mx plus c. What will you consider if your variance is high and bias is low? High variance and low bias. I think it's underfitting, right? I am not sure, but high variance and low bias. So you can think of it this way. So let me open up. Well, let's say this is your target. Okay, and this is your center. Now, if all your predictions lie here, you want your predictions to lie as close to the center as possible. So the closer these are to each other, that's the variance. Low variance would mean that all your points are close to each other. And a low bias would mean that the cluster is closer to your center. Okay. Now, high bias and sorry, you mentioned high variance and low bias. So when your bias is low, you are more likely to be towards the center, right? But when your variance is high, you tend to differ, or your predictions would be like this. So this is an example of underfitting. So low variance and high bias would be an example of overfitting. Or it's the other way around. No, I think that's. But yeah, do cross check. Okay. Two different algorithms give the same accuracy, then which one do you choose? Great. Now, if two algorithms give you the same accuracy, first of all, that's not possible, right? Because you'll be checking till 3 or 4 dimensional spaces. But if two algorithms give you the same accuracy, try to change the test and train set. Okay. Let's say in first set, you had X in train, Y in test. Use both the algorithms, they give you the same accuracy. Now change it. Choose some different variables or choose some different data points in test or train now, and then see what's the accuracy. But even after doing everything, both of them give you the same accuracy, and both the models are good. Great. So do we have anything else? Let me just go back. Any other questions, guys? Let me go back to the check. You'll receive the Excel file. I'm not sure. I don't know. Yeah, I have no problem in sharing it with you guys. Anything else, guys? Any other questions? Thanks a lot. Bye bye.